Okay, so the question's been asked, how do you tune this thing? Well, that's pretty well set up by the dynamics of the exciter, the coils, and the actual geometry of those electrodes itself. So what we will do is go over here, show you the next thing. We need to look at the spectrum analyzer, and what I'm showing right here is a width of 500 megahertz. The span is 500 megahertz. The center frequency, which is right in here, is 250. You'll see we actually have signal out here to as high as, let's see, 470, 423.8. And as we go down in frequency towards the FM band, which is right here, you'll see that the signal increases, the strength of the harmonics. And what I'm going to do is go ahead and shut this down to a narrower bandwidth. We'll go ahead and put a span in here of about 200 megahertz. I don't want 500, I want 200. And we'll put the center frequency at 100 megahertz. And okay, you kind of see now what you're going to have to shoot for when this is tuned. This has now, consider this as absolutely, totally different parameters than what you see in a wireless SEC exciter, one-wire SEC exciter, or SEC itself. What we're shooting for here is right here. You can tune the exciter visually and try to get it to where you're getting maximum gas, lowest current, but that isn't as telling as this right here. So what I want to do is I wanted to show you this is a bandwidth of 200 megahertz. The center here is 100 megahertz. This is actually what we tuned to. Let me go ahead now and take and reduce it again. So what I've done here is I have a bandwidth of 50 megahertz. The center frequency is 25 megahertz, and here's what we tuned for right here. So let me go ahead and move the marker over, and what we're shooting for when we set this guy up for maximum gas production is approximately, and of course we have to allow for the accuracy of the signal that's read on the spectrum analyzer. We only go to 1 decimal point, but actually what it's reading here, you see, is 46 megahertz. So actually, if you have an SA, you can take and tune this for a maximum peak at 46 in the evaluation kit, and you should be at the point of maximum gas production. Now that's with the electrodes, with the coils in the evaluation kit. If you attempted to replicate this yourself, you'd have to know all of the dynamics and stuff, and you most likely would not be able to achieve that frequency at all. Now the way I'm picking this signal up is just strictly with an antenna on the SA. So that pretty well tells you that it is different than what you normally see in a SEC exciter. You got to remember we're dealing here with electrolysis, the liberation of oxygen and hydrogen from those electrodes, and it's not the same thing as what we're doing with the wireless communications or the one-wire communications. So also what I did here is in one of my videos I pointed out this insulator down here that I had on the large bubbles that formed there. And so what I did is I took and actually cut the insulator down, and obviously what happens is what we would expect. We now get more gas production right down here where the insulator was not separating the large outer coil from the two inner ones, and we still get this large bubble formation, but not near the size that we had before. And yes, indeed, it is still producing bubbles on the edge of that insulator, but obviously there was a phenomenon that takes place there. That's really not what we're striving for. We're striving for maximum production. So the actual evaluation unit, of course, will have a little different insulator arrangement down here anyway, but I just wanted to show those anomalies, and everything works as expected. The thing you'll notice though is also on the evaluation kit, this coil will not be as large. The outer coil will be shorter. The reason for that is it's not necessary. If you see here, you'll see very little production though from this exposed coil. The electrostatic field buildup in here is allowing for full production on the two inner electrodes, but very little here. As you move up the coil, you see it's greater and greater and greater. So it's really not necessary to have even this wire down here on the coil because it's not benefiting all that much to the circuit. So anyway, I thought I'd throw that in, show you the spectrum, and we'll get on with our work.